Welcome back to our statistics learning session. Today we'll be talking about statistical formulation of hypothesis testing. For this, we'll deal with lots of random variables, so bear with me. Lots of grid variables, so bear with me. I will try to explain those. Let us start with the sample observation, and let there be an observation, and let each observation be a random variable, and this observation should be in our sample space called E, and then P sub theta for theta in theta be our parameter space. Why do you want to use this modeling or statistical formulation for hypothesis testing? We want to do this because it allows us to do all possible tests at once in one unified theory. That means if you have a statistical model, it allows us to treat all kind of tests at once. As a next step, we need to split our theta, which is the parameter space, into two parts. Let me draw the parameter space capital theta here, and capital theta will be broken down into two parts: small theta null and theta 1. Here, this theta naught and theta 1 doesn't need to cover whole theta space, but it can cover only subset of that. Let's assume that this is a no man's land here. Next important thing is that theta naught and theta 1 has to be at this joint. They cannot overlap, else we cannot formulate our hypothesis. It will not work. Next step is to actually formulate the hypothesis, a scientific hypothesis based on our parameter theta. For this, we'll start with some English. Let me give you an example. Let's say if you want to ask a question, is the Princeton Plainsboro Hospital average time is hospital's wait time is worse than national average? Is that it? That's a question we want to answer. How do you do this? We can do this by creating a statistical model out of this simple English. For that, we need to create the mean of Plainsboro Hospital, the mu wait time of Plainsboro Hospital is smaller than 30 minutes and mu is greater than 30 minutes. This is going to be the H naught and this is going to be the H1. That's how we're going to do it. We have to create two hypotheses for Plainsboro Hospital if you want to see whether you want to prove whether the mean average waiting time of Plainsboro Hospital is greater than national average, which is 30 minutes. Here we started with a simple English. Now we want to know what does parameter look like, and when I mean parameter, it is a probability distribution. Can we, if you know the parameter space, can we go into probability distribution? Yes, we can, because look at this. This is a parameter set theta naught here, and this is a parameter set theta 1, and this is a whole parameter set. Look at the area covered by these two. Can we find the area covered by this parameter space and the parameter space of area covered by this one? And if we divide it by area of theta naught by area of theta naught plus theta 1, then we would find the probability distribution of theta naught. That's how we can move between parameter space theta and probability distribution. But only thing is that the theta has to be identifiable. We can pinpoint, okay, this is a theta, and we can move between probability distribution and theta parameter space. Is that understood? Okay. Now moving on to next step. When we are writing or when we are writing a hypothesis, we are asking really whether parameter theta belongs to theta naught or theta 1. Here, theta naught is the null hypothesis, while H1 is called here the first one, which we have this H1, H naught is called null hypothesis, while H1 is called alternative hypothesis. H1 is one that associated with the theta naught parameter, and H1 is one that's associated with the theta 1 parameter space, I have to say. What we are really doing is we want to test H naught against H1 or null hypothesis against alternative hypothesis. When we are doing our analysis or data mining, we are looking at for any evidence against theta naught in favor of H1. For analogy, let's assume that H naught is a small island. We are sitting on it right now. Then we are looking at a particular direction from that island to another place called H1 or alternate hypothesis. And we are looking at the data and looking that whether should I be really in this island or should I be moving toward that direction. That's the thing we are trying to decide here. And another thing is that, and let me give you another one more example of a jury in our legal system. Let's say some let's say a, a person is caught by police and taken before a judge, and we have a jury. Now the jury passes a verdict at the end. Is that right? Yes, that is true. What does the jury say? They say that this person is not guilty. This They don't say this person is innocent, but they say this person is guilty. Meaning we did not find enough evidence that this this evidence against this person to make him a guilty. Here, the burden of proof is upon the prosecutor to bring enough evidence against the person who is being prosecuted. Now, when a jury gives their decision that this person is not guilty and the person walks away free, that doesn't mean that this person is innocent. It just means that we cannot find enough evidence that this person is guilty. That's another beautiful analogy of the hypothesis testing. Now, one more thing we need to understand here is that we start with the assumption that S naught is true, and we are looking for a data and we are trying to find a contradiction against it. But if you don't find enough data in the, we do not find evidence in the data, it doesn't mean that H naught is true. In this way, H naught and H1 play asymmetric role. Therefore, we have to be very careful in choosing which hypothesis will be H naught and which hypothesis will be alternate hypothesis for our hypothesis testing. That much for today. Let me quickly summarize what we discussed. We talked about statistical formulation, and we started with a sample of random variables and sample space E and the parameter family P that whose parameter belongs to a parameter subset theta. Theta can be further subdivided into theta and theta naught. Then next step is to create two hypotheses, H naught and H1, which are called null hypothesis and alternate hypothesis respectively. And we also said that we start with the H naught as a true thing or S naught as a true, and we look at data to prove that S naught is not true. If we cannot find evidence that S naught against if we cannot find evidence that S naught is not true, then it doesn't mean that S naught is true. Well, that's all for today. I'll see you next learning session. Thank you so much.